What questions on the homework do we have? Luca. 19. Was there a specific part or just kind of all of it?
Kind of all of it, and also, like, I guess, why did you split it into x minus 3 and 8?
Okie dokie. So, here's kind of the whole thought process that would go behind. Because first I would look at this and go, I wonder what to do here. Now, one thing that would make me suspicious, forget the fact that it's in the section with inverse trig. One thing that would make me a little suspicious is why they wrote the radicand the way they did. Why did they write it as 9 minus the quantity of x minus 3 squared? Why not just multiply it all out as quadratic in standard form? There must be a reason. So that would make me start thinking about arcsine or arctan or one of those. And then, of course, it's the constant minus the variable, so that makes me start thinking about arcsine. So now I've got arcsine on the brain. So, but then in the numerator, I noticed we have a variable plus a constant. And we saw this with arctan. I can't remember if it showed up elsewhere on your homework or if this was the only one. But as you start seeing more of these, you'll start to recognize them. But if it's going to be an inverse trig, I mean, first of all, that could be du just sitting there in the top. So we could look at this one easily and go, okay, well, u has to be x minus 3. But du would not be x plus 5 then. So that's not du sitting there on top. So that would make me think about splitting it. And so that one part's going to be one kind of problem and one part's going to be the other part. So the constant, and I'll talk about why it's an 8, but the constant over the radical, that's going to be the arcsine. The variable over the radical, that's going to be something different. Now, last time when we saw arctan, there was no radical in it. That was a natural log, so we could say we have the derivative of the bottom and the top. But if we tried to say we have the derivative of the bottom has a square root. The derivative of the bottom should also have a square root. We don't have a second square root in the problem, so I'm not thinking about natural log. But it is a composition, so that makes me think about u substitution. So if I let u equal that inside function, then du is this. So any questions just so far? Because seriously, this is what would be going through my brain. All right, so here's du. So now I'm going to see if I have that in the top. And oh, I have an x minus 3 in the top. I don't have the negative 2. So I'll do what we always do. We move it over so that now this x minus 3 dx is clearly up there. The reason why I need to do x minus 3 is, and because like even before this, we could look at the bottom. The inside. We could look, like, if you think in your head that this is going to be u, Godzilla. Du is going to be 2x plus other stuff, whatever. But hopefully you guys can see that it's at least going to be 2x. But we only have one x in the top, so it helps to write it out. But I'm thinking about this right here. So this is where it does get a little tricky, because I can't just. I mean, there's ways to, anyway, the way I look at it is I just have an x, not a 2x. So let me write this out so I can see it. And I can get it down so that there's just 1x instead of 2x. And when I get it down to 1x, it's an x minus 3. So that's what I want to put in top. But if it's going to be equivalent to x plus 5, I still have to add 8 onto it. Does that make sense? And then once we have that, then it's just two separate problems. You just add them together at the end. So does anybody want me to walk through the two separate problems now?
Can you explain
Why it's 8? Yeah, so here's kind of I'm basically going to write down the same thing, but here would be my thought process in order. So I know I'm going to split it up so that over here, this is going to be the arcsine. I'm just going to put arcsine here. This is the arcsine problem. So I'm going to put a constant up here. I don't know what the constant is. I'll have to come back to that. But over here, I have this. And I've narrowed it down to u substitution. So I'm going to let u equal the inside 9 minus x minus 3 squared So du is negative 2 x minus 3 dx. But I look at what I got. I only have 1x. I don't have a 2x. So I'm going to move that 2 over. I'm going to make it negative 2 du equals x minus 3 dx. So I want an x minus 3 up there. So I know to put now x minus 3. So now to keep this equivalent to x plus 5, I still have to add 8. And so now I know the constant over here is going to be 8. Yeah, Marcus. Oh, yeah. Boop, boop. Any other questions? Yes?
Could you let u equal to x minus 3?
You might be able to. There's often lots of things that you could let u equal, and looking at this one, that could work too. I don't know off the top of my head without working it out, but it's likely. Any other questions? Any other questions on any of the other problems? This was definitely a doozy. Well then, could I have your homework? And yes, we do have a reality check. Oh! Yeah, it's a slow burn. But I actually like this game. There's a lot of action, but it's a lot of story. So I actually really like it. But there's only been 6 episodes so far. Like the last 2. Did you guys the season finale? And oh! That can happen, I don't know. Yeah, well, so there's the current time in the show is when he leaves the Mandalorian and takes over Habitat, but there's a lot of flashbacks. So you actually get to see how he's getting Sarlacc there, and then how did he get with the Sand People? And yeah, so you get a whole lot of backstory that way. Anybody watching the Book of Boba Fett?
Not yet.
Oh! I gotta talk about it with somebody. You guys watch it. You ever hate that when you're like into something but nobody else is? You can't talk about it with anybody but you want to? Oh yeah. Harry Potter, the second to last book. I forget which one that was. But I read it, and then nobody else had that I knew. So I go online to like maybe people are talking about it online. So I go and look at like forums, like Harry Potter forums. Let me just say that some of the things that the boys were saying about Hermione Granger, very not okay. I was like, ew, this is gross. I can't watch it. No. So I just had to wait for people to read it. All right. Anyway, you have a reality check. There are 3 problems. They're not too bad. Remember, we're spending the same 2 days in this section, so this first reality check on this section is going to be fairly basic. I'm going to put some more interesting ones on Friday. So I'm going to give you guys, we'll see if 6 minutes is enough. If it's not, I'll go up to 7, but I won't go any more than 7. All right, does everybody have one now? You may begin. Oops, I'll pause. And there's 1 and 2. 1 and 2 were pretty straightforward. 3 wasn't too bad. It didn't look straightforward, but when you actually start working it out, it turns out, oh. But anyway, any questions about the first 2? Anybody want more time looking before we go to number 3? All right, so there's number 3. So, as I was picking it up, I heard people talking. Oh, yes.
Yeah, I don't know.
So if it was x to the 6th,
That's so much easier.
if it was x squared, would we be able to do it?
There must have been a right answer.
I'm not even sure, actually. I'm trying to think if it was x squared, what you would do. Maybe when I give you guys something to work in, I'll try to do it as x squared. I'm not sure if we have this stuff to do it. Yeah, okay. Well, once again, it's going to be out of 2 points. At least that's one I can fix for the other classes. Yeah. So let's do today. Today, there's nothing new, but I have a lot of stuff I'm going to give you. And I am going to still give you something to do for notes. So, well, actually, let me tell you the stuff I'm going to give you. Because while you're working, I'll give you all this stuff. So I have one handout. This is just a reference. I know nobody can read it, but you can see this big gray box. This big gray box has all of our derivative rules from the year to know. On the back is another big gray box, which is all the integration rules to know. So this can be a reference sheet for all the formulas. So you're going to get this copy today. The other thing I'm going to give you, remember tonight's homework is still off of the integration with inverse trig. So this is not your homework packet for tonight, but it is the review stuff. So if you want to start looking at that, I'm going to go ahead and hand out the review packet. And then, as always, with a disclaimer of do not think that this is the only thing that you should be studying in order to get ready for the celebration. This is just a tool, but and also anything that we've done in previous units is fair game. I am not going to give you one of those topics for the unit celebration because honestly, this was just a bunch of integration and differentiation rules. This sheet is kind of like your topics if you want. But again, I also could ask stuff from previous units, just like we've seen show up, like the tangent line, average value, like any of that stuff could still show up. But this was the main topic, was just finishing up our integration and differentiation rules. I'm going to give you guys these 2 things. But what I want you guys to work on now is, here are 6 problems. I'm going to move number 6 so I can fit it on the screen and make it small enough. But I want you guys to try these 6 problems. We'll go over them. They may start off kind of simple, but there are some doozies in here. So take a gander, see how you do. I'm going to give you a good chunk of time. If you happen to finish them, that's what I'm giving you all this other stuff for, so you can start tonight's homework. If you want to start looking at the review, you can. But let's see, it's 8:35 right now. How about 9:10? At 9:10, we'll come back and start looking at the answers. So back at 9:10. I'll put it right here. Back at 9:10. And I shall pause the recording now. Here's the answer to number 1. A little warm up. Hopefully that wasn't too bad. Yes, Rena. It's a good idea to. I'm not going to say you have to anymore, but definitely if my directions say to, definitely do. Yes, Joe. 1/5. Oh, where did it come from? Oh my God. Thanks. That's a stupid. This 1/5 that I put out in the radical needs to come down for the ride. So 15. Thank you. Yes. So in general, we rationalize when, but again, it's in general. You won't see it every single time. But if it's just numbers, like the coefficient, then in general we do. In general, when there's variables, we don't. But it's all in general. Any other questions? Ready for number 2? Oh. What is number 2? I don't remember which one. Each one had their own little fun, huh? Did anybody get to the last one, number 6 yet? A few people. All right. Was it fun? Yeah. I don't know if I did either, let's just say. Anybody still need number 1? Right, number 2. Now with number 2, remember you have to have u on the outside of the radical. And if you're going to let u equal 11x, you need an 11 down there. But if you put an 11 down there, you can put it up there and you're okay. And that actually worked out convenient because that gave us du right on top. Oh, du should just be 11. Whoa! Come back. 11x. That's silly of me. Yes, Joshua. Because I'm making sillies. I'm being careless. I really hope you guys hear that on the recording. I don't know what that was. Let me see if I can make this not look like the 11, though. Let's hear. Absolute value of 11x. Absolute value. Thank you. The 11 could be pulled out of the absolute value, but the x definitely has to be in there. Any other questions? Let's see if I can get number 3 all right. But you know what? Actually, I'm definitely not doing most of these mistakes on purpose. But what's awesome is that you guys are understanding this well enough to catch me. And that's good. That's actually really good. Anybody still need this one? All right, number 3. How'd I do? Now remember, when you complete the square, you cannot complete the square unless the coefficient of x squared is 1. Right now it's -1. So you have to factor out the negative and then complete the square. So watch out for that little trick. And then when you add 25 to complete the square, it's really -25. So that's why I added 25 again to cancel it out. I got one. Yeah. Any questions on this one? Yes, Trey. It honestly, actually, it could happen. We've seen it happen before with trig, and we might be off by a constant from each other. So you may have done it correctly. Hold on 1 sec. Does anybody still need this one? Okay. Actually, we could. That's true. Copy. Okay. Trey, tell me again what you got. Wait, square root of x over square root of 10. All right. What did you do?
Okay, so there's that, and I got negative 2 arc sine of square root of 1 minus 1 tenth x.
Wait, square root of 1 minus 1 tenth x. Oh, okay, like that. Wait. Is there a like this? Okay. So hang on one second. All right. I'm going to go ahead and put in the first answer, maybe. Oh, there we go. Arc sine of x minus 5 over 5. And then plus c, but we can't do that in Desmos. All right. And then we have 2 arc sine of square root x over 10. It'll just end up being all being in the same thing. Why is it? She didn't have to. It's all under there. Really?
Oh, arc sine has to be.
Wait, what? No, the argument does, it's saying.
Yeah, the argument.
But it's a square root, Desmos. Okay, so look, we're off by constant, and then negative 2 arc sine, square root, oh, wait. Yes, Desmos. Square root 1 minus 1 tenth x. They're all equivalent. They're off by a constant. So, there's different approaches, and I've seen it happen with arc sine. Like you can get these completely different looking answers, and so remember the thing is, and we don't know identity. We haven't learned identities with the inverse trig. But if you remember, actually, it's a test you guys just got back. Remember that one question where I had you do the integral of, I think it was just cosine sine, and I gave you one thing to substitute in for you. I gave you something else to substitute in for you. Those answers aren't dramatically different from each other, but they are different, and then it turns out you can use identities and the plus c to show that they're equivalent. It's the same kind of idea that's happening here. So you guys just did it with different approaches, because there are different ways, and then you still get an equivalent answer. So it can happen. Interesting. If we have time, we'll take a look at how you guys, I'm imagining you guys probably did a similar approach to each other, just getting slightly different things. So yeah, pretty cool. I'll actually put it, let's see here, let's go back. Here, we don't need that again. Just put a little note here. If anybody is going back and studying and wants to try other things to see if you can get these answers, or seeing if they're equivalent. Anyway, some other possible answers. I'll just leave them up there. Nice. All right, any other questions, comments, anything on number 3? All right. Number 4. Number 4 was one of those fun ones where you don't quite have the derivative of the bottom. You got to adjust for the constant. Is that what you got then? You got it. Yeah, the 47 definitely stuck out in my mind because that's a common thing. All right. Where to get what? So I never actually used substitution with this bubble, but this is just kind of what I'm thinking about. You know, there's no square root in the bottom, so I want to think about natural log. Derivative of the bottom and the top. Derivative of the bottom would be 2x minus 10, but I don't have a 2x, I have a 10x. So what do I have to do to the 2x? To make it a 10x, I have to multiply by 5. But that means I'm going to multiply du by 5. So that's where that 5 is coming from. That 5 is telling me 5 times 2x will give me the 10x. That's how I think about it to get that 5. But somehow you need to get that 5 to make this 10x. It's too much fun. Any other question? I wish I could make the laser pointer a different color. Good notes. If you're listening to this video, make the laser pointer optional, like the different colors. I want green. Yeah. And I can make flowers. Anybody want more time on this one? Okay. Anybody need more time still? All right. Here's number 5. That's it. You got one of those other answers again? You're going to put it on Desmos? There are, like, I'll tell you this one. So, and it might have been something similar on the other one. This one right here, if you distributed the x into the denominator, or the radicand, because they're both in a square root, so you could multiply these together, then you would get something to complete the square on. And if you complete the square on it, you actually will get a totally different looking answer, but it's equivalent by that plus c. Silver.
I got something slightly different. I got 2 arcsine 2 root x plus c.
2 root x plus c.
Because I had u equal to root x.
That wouldn't be equivalent because that would just stretch it. So if you, let's go ahead and do that. I'm going to save this answer here. So if you let u equal square root of x, then du would be 1 over 2 root x dx. We have the 1 over x. That's good. But we don't have the 2, so I'm going to do 2 du is 1 over root x dx. So what happens here? I'm going to go ahead and just... So if I have... I'm going to go ahead and rewrite the original problem here. 1 minus 4x dx. So here's the original problem, and remember, how do I want to put this? Hold on, I'm thinking here. Actually, yeah, a whole bunch of things are going to change. So did you do, well, okay, sorry, words, hard. What did you do?
So, I rewrote that to get 2 times the integral of du over 1 square root of 1 minus 2u squared. No, the 2u.
Boop, boop.
And then I got 2 arcsine 2 root x plus c.
So 1, that looks right. So 1 over root x dx is 2 du. x is u squared from that, and then the 2 is squared, so that's equivalent. Ah, yeah. So the problem is you do need, in the arcsine formula, whatever is squared, you need the derivative of that on the top. And so this 2 would actually go here to take care of that, and then it doesn't appear as a coefficient. But yep, there's another thing that another approach for it. Any other questions or comments? All right, and then finally, number 6. So let's just first look at, because then I'll scroll up, the area. Remember, to find the area, I'm telling you that the interval is going to be from 0 to 1, and I'm telling you what the function is. So any questions just setting up the integral? Because then I'll scroll up so we can see all of it. Okay. So then you get a not so pretty looking answer. And I don't know how to make this thing go away. Oh, I can move it. Okay, that works. And so there you go. So you're going to have to split it. They're not so bad, each one. Any questions? You guys are becoming integration monsters, rock stars. Yes, Rena. Like from the very beginning? Right here? So from here to here, let u equal x squared? It probably would. Because if you let u equal x squared, du would be 2x, and you have, well, but then still, how would you integrate 1 over root 4 minus u? You still have a problem. Well, no, because you're only off by a negative. It could work. Yes, it could work. Any other questions? All right. Let's go back to that weird one where we got the weird wonky looking answers. Let's see what they did. Does anybody still need this one though before I leave it? Okay.
Wait, okay, so you have -4, and then you have minus root 4. Wouldn't that be -6?
This right here is 4 times 0.
Oh.
Sorry, when I asked the question, I didn't pay attention. Anybody need this still before I scroll? Okay, let's go back. Where was that one? This one. All right, I don't know. Marcus or Trey, either one of you want to tell us what you did? Yeah, or at least get us started so we have an idea of another approach to this. I'm just leaving it as one fraction, but do I have it right? Is that okay? U is this? Sorry, is that big enough? Like that? Looking good? Yeah, and then we can see it from there. But, yeah, using this substitution, you still get an arc sine problem. But the arc sine, if you look at this, it looks so different from that. But it does wind up because of that plus c. Yes? So instead of 10 minus x, you did square root of x? And so that's why you got something kind of close. Yeah. So there you go. Different ways of doing this. This is why it's going to be so important. Show your work. All right. I'm going to go ahead and pause or stop the recording and